All right, let's get to the next set of 5 problems that I call rapid fire. 2024 AMC 10A problem 11. By the way, right now it's about 3 a.m. local time, and I'm going to stop filming and start editing and uploading around 4 a.m. So I might not get to problems past 15. If you're watching this video and looking for those, I'll film as soon as I can, but it's kind of a grind to get it out, and I'm up all night and pulling an all-nighter, and I got work tomorrow. So doing what I can. How many ordered pairs of integers mn satisfy the square root of n squared minus 49 is equal to m? So kind of a thought process is that's a perfect square, that's a perfect square. You have the difference of squares and it needs to be a perfect square. Not a lot of options with that. It's kind of a lot of things going on. Why don't we just square both sides? So if we square both sides, then you're going to get n squared minus 49 equals m squared. Now we know m is positive, so we don't have to worry about plus or minus or anything like that, because you're taking the square root of something, it's going to come out to be positive. So then I would put the 49 over here, the m squared over there, and we're going to get difference of squares. So with that being equal to 49, we know n and m are both integers because they told us. Therefore, the sum of them is an integer. This is the second time we've seen this concept on this test. Should be kind of warmed up for it by now. So if I let n plus m equal 49 and n minus m equal 1, okay, then n plus m is 49. I get 2n equals 50, so n is 25. That would make m equal to 24. So you get 25 comma 24. Actually, the other way around. 24 comma 25. Okay, great. What about, though, could we do negatives? Is there a way that we could get a negative result? The answer, no, because m's going to need to be positive, unfortunately. You don't get to, if I take the square root of, say, 16, it's only equal to 4. But wait, I remember in school we had plus or minus. Well, yeah, but that was when you had x squared equals 16. And it's because when you square root a perfect square, that is the definition of absolute value. So technically when you did this, all you really got was 4, just as you get it right here. But when you peel off the hidden absolute value indication, then you're going to get plus or minus because of that. But if I start with x equals this, then x is only 4, which means m has a restricted domain. It must be a positive integer. So if m is positive, is it possible that n could be negative? Maybe we shouldn't give up on this idea just yet. Let's see. Maybe I could do n plus m equals negative 49, and n minus m is equal to negative 1 somehow. Let's just see if we could do that. Then 2n would be negative 50. So n is, in this situation, negative 25. Problem though, if n plus m is negative 49, that's going to force m to be negative 24. Let's try something else. Let's try n plus m is negative 1 and n minus m is negative 49. Then n is still negative 25. But now, if n is negative 25, and I add m's going to have to be 24. So I could do 24 comma negative 25, no problem. And that would make sense because n's getting squared. Of course, the negative version should also work, but our m value didn't change. Now we can check that on this one. If I do negative 25 and I subtract 24, indeed I do get negative 49. So you can do the negatives over here because even though m can't be negative, doesn't matter. We can still do it with n. Okay, but now let's go ahead and do it with 7 as well. Let's say n plus m is equal to 7 and n minus m is also equal to 7. Is there a solution for this? And you say, well, wouldn't that make m 0? Yeah, and n can be 7 and m can be 0. So you can say 0 comma 7, but let's play the same game again. Can't n be negative 7 and 0? Why, yes, it can. 49 minus 49, gonna give you 0. You can see we're pretty restricted right now, and this is kind of absurd, but just to be sure, you're taking away 49. Why can't we just keep going up infinitely and get a bunch of different perfect squares? And the reason would be that you need the result of this to be a perfect square. And again, we said before that as you go up, numbers, the difference in consecutive squares, earlier in this solve process, one of the earlier videos, we said the difference in consecutive squares is the sum of their bases. So if you made this 25 squared minus 49, basically, how can I think of this? If I think of this as x squared, right? X squared is some perfect square. Then if I do 25 squared minus that x squared equals 49, you're kind of just doing the same thing with the m that you had before. I'm thinking about like how 24 and 25 have a difference of 49. If you went up any higher than 25 here, like 26, the difference between 26 and the next perfect square smaller, I don't think it's going to be able to be 49. I don't know, I'm trying to think of this thought. It's late, it's 3 a.m. I don't think you can find them. I'm 100% sure that you can't. Just the squaring of the other side and doing this process here kind of ensures that. The answer is going to be 4, but again, you might play around with that idea. It's a little late for me to think about why that doesn't work exactly. Have high confidence. The answer is going to be D. Let's get to problem 12. Okay, let's do now problem number 12. Zelda played The Adventures of Math. Somebody at MAA is a Nintendo fan, because there's a Nintendo game called The Legend of Zelda, or The Adventures of Zelda, something like that. I'm pretty sure of it. So they played The Adventures of Math game on August 1st and scored 1,700 points. She continued to play daily the next 5 days. The bar chart below shows the daily change in her score compared to the day before. For example, Zelda's score on August 2nd was 1,700 plus 80. So she started on August 1st. This is August 2nd. She now had 1,780 points on August 2nd. What was Zelda's average score in points over the 6 days? Daily change in score from August 2nd to 6th. Here's the bar chart. Now, we'll do what I did first, and we'll see what you think. So I said, well, from 1,700, if I add 80, subtract 90, I'm at negative 10. Negative 10 more is negative 20, and negative 40 is negative 60, and 60 plus is right back to 0. So she net averaged 1,700, so it's just A, right? We're done. We're ready to go to 13. Did you think this was AMC 8? Did you really think you were just going to do that and get it? Yeah, so I did that. And then I thought, wait a minute, spider sense tingling. I think I better check over what I was doing and make sure that's a valid approach. I mean, it seems nice. It works out perfect. My answer's right here, but it's not going to be correct. And actually, that's how a lot of the answers come up, is they anticipate what kind of mistakes you might make, like that one, for instance. And that would be probably a great plan had this been the difference from 1,700. But instead, it says that it was her change compared to the day before. So August 1st, you're going to have 1,700. Now, it does say over 6 days, and you are stopping on the 6th, so you do need to include the first. Second day, she scored 1,780. You have to lose 90 from this, not from 1,700. You go to 1690, you lose 10 more from there. Then you go up 60, you're at 1740. Then you go back down to 1700. Okay, so if you think about it now, compared to 1700, if we use the same method with that in mind, you do have plus 80 here, minus 10, minus 20, and plus 40. So you have 120 minus 30 is plus 90 from an average of 17. If these are all 1700s, you'd have a net gain of plus 90 on top of that. So it's like having 1700 times 6 plus 90, which is 6 times 15. So all you have to do is divide by 6, and you get 1715, answer choice E. So your idea in the beginning that would result here is a good idea. You just need to do it at the right time. Let's go ahead and try number 13. And now problem 13. Two transformations are said to commute, like commutative property. In the original text, it's italicized, but I can't italicize with my pen very well because I don't know calligraphy. So I just underlined it. Commute if applying, commutative property is the one where you do it like 3 plus 5 is 5 plus 3. That's commutative property of addition. So taking that concept, they're saying that two transformations, if applying the first followed by the second, gives the same result as this applying the second followed by the first. Consider these four transformations of the coordinate plane. I'm not going to read them yet. Of the 6 pairs of transformations from this list, that would be 4, choose 2, how many commute? So I'm going to call these, basically just for notational purposes, transformation A, B, C, and D. Not like the answers, just transformation A, just using the same letters, but that's not what I mean them as. You basically want to do A with B, A with C, A with D. Check, 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 does it work? B with C, B with D, and C with D. And then you just test each one. So a translation 2 units to the right, and you can do this with a general ordered pair like X, Y, but I'm going to choose not to. I'm going to use a specific ordered pair because it will work for all the ordered pairs in the plane. They all have to do this. So if I go with the ordered pair 2, 1, and I translate it 2 units to the right, that's 4, 1, and then a 90 degrees rotation counterclockwise about the origin. Now, if you don't know, X, Y, 90 degrees counterclockwise is negative YX. But I do happen to know that one. I don't know most of the transformations like a map. Some of them are in my small notebook. They might be in yours. But you can figure it out on the fly, which is why I don't consider them that important to know. So for example, if you're at the point 4, 1, and you rotate 90 degrees counterclockwise, this point, which is 1 unit off the x-axis, will be 1 unit off the y-axis on this side. And you'll know then you're at negative 1, 4. So you can kind of figure it out even if you don't know that. So that would put you at negative 1, 4. Okay, now what if I did the rotation, rotation first? 2, 1 would then become negative 1, 2. And then negative 1, 2 going 2 to the right would become 1, 2. X is going to gain 2. Those points are not the same. Therefore, the AB does not work. Let's check AC. So AC would be I take this ordered pair, and why am I using 2, 1? Randomly chosen so it doesn't have both 1s or the origin or something like that. Even though those points probably work too, I was just using it to be safe because I didn't want to think generically with the XY coordinate. So a little bit easier on the brain to use numbers in my opinion. So then 2, 1 is going to again move 2 to the right and become 4, 1. And then now it's going to be a reflection across the x-axis, which is going to be 4, negative 1. Then I'm going to do the reflection first and be at 2, negative 1. Again, y becomes negative y. And then move 2 to the right. And where are we? We are at 4, negative 1. Therefore, under my notation, the AC transformation is commutative. Let's do the AD one. Again, I'm going to erase here really quick. 2, 1 is going to become, this is with the translation 2 to the right, is going to become 4, 1. A dilation in the plane centered at the origin with a scale factor of 2, you'll just double your x and y coordinates. You're getting twice as far away from the origin as you were before, and so that's going to become 8, 2. You can think of it like similar triangles. If you scale it out, double the x, double the y, the hypotenuse, which would be the distance from the origin, will also double as well by similar triangle properties. So then 8, 2. Now, if you're at 2, 1, and you first dilate by the plane on this D transformation, you will go to 4, 2 by doubling x and y. Then go 2 to the right, you're now at 6, 2, and that's not the same as 8, 2, so AD does not work. Let's go to BC. I'm going to go ahead and clear this off. And, oh yeah, I think I accidentally erased a 1 right here too. There's a 1 there. Okay, so now B, a 90-degree rotation counterclockwise about the origin. So 2, 1, 90 degrees counterclockwise would become negative 1, 2. Again, using this up here now that we learned it. Once you know what it is, you can demonstrate it to yourself and then make the map. And that's why I just don't memorize it all the time for all those things. So negative 1, 2, and then you're going to go with C, a reflection across the x-axis, which becomes negative 1, negative 2. Now what if I did the reflection first? 2, 1 would become 2, negative 1, and then I do a 90 degrees counterclockwise rotation. The negative 1 becomes positive 1 in the first position, and the 2 goes over here to 2, and those are not the same point, so BC doesn't work. Let's do BD, B with D. So 2, 1, I do the rotation first. That's still going to be negative 1, 2, and then a dilation centered at the origin, so doubling both values, negative 2, 4. Okay, then what if I did the dilation first? Now I'm at 4, 2, and then you do this mapping thing that y becomes the x coordinate, but negative, negative 2, and the x becomes the y coordinate, and those match. So in fact, BD does work. Let's check CD. A reflection across the x-axis. Again, I'm going to take 2, 1, and I'm going to reflect across the x-axis, and it's going to become 2, negative 1. And then you're going to dilate from the plane by a factor of 2. You're going to be at 4, negative 2. Let's do the dilation first. You're at 4, positive 2, because doubling this, doubling that, and we're going to flip over the x-axis because a reflection across the x-axis was the C1, and of course that does give you 4, negative 2. It matches, so the CD transformation does commute, and you get 3 commutative transformations. Answer choice C. On to problem 14. Let's get going with 2024 10A now. Problem 14. One side of an equilateral triangle of height 24, not side, lies on line L. Okay, let's start drawing this. So we're going to have some line, we'll call it L, and there will be an equilateral triangle. Its height is 24, which means that you get 30, 60, 90s. This will be 12 and 12. No. You have to divide by root 3. Just kidding. So 24 over root 3 is 8 root 3 and 8 root 3. And then that is going to double to get 16 root 3 over here. Okay, then what? This is line L. And it says that a circle of radius 12 is tangent to L and is externally tangent to the triangle. Is it down below or over here? Let's see. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and line L. See, if you put it down below, there is no region bounded. Therefore, it must be going on the side over here. And it says, and bounded by that, the circle and line L can be written as blank. At that point, stop reading. You want to find that region. You can read the rest of it later when you found the area that you're looking for and make sure it's in the right form at that time. All the rest of this is some kind of standard language for ending of the problem. Sometimes the square root could be not simplified, sometimes it is, but worry about that later. Focus on the task at hand, which is first drawing a circle. And that circle needs to be tangent to the triangle and to line L, something like that. Now, if it's tangent, these are small notebook concepts now, we covered these in that class, you're going to draw the radius to the point of tangency. The moment they tell you tangent, draw it, make 90-degree angles. And you've got that here, and you've got that here. Now wait a minute, opposite angles of that quadrilateral that we're looking at, if I call this O, and I call this, I don't know, is there any letters up here, A, B, C or anything? No. Then we'll call this A, B, and C. OABC is a cyclic quadrilateral. The reason that it is because the opposite angles are 90. So we could use that if we wanted. Furthermore, being that the triangle is equilateral, this angle down here is 120. And that makes the central angle here 60. So then what you're going to need to do, because the opposite angles add to 180, you're going to want to find the area of OABC and then simply subtract the sector of the circle. Sector area is simply 1/6 because 60 over 360, the area of a circle, pi r squared. So all we need now is OABC. How are we going to get it? Well, not only is it cyclic, it is also a kite. How do we know it's a kite? The radius, it said what? The radius was 12. That's 12, that's 12. And this length from, I'm going to erase this 8√3 for a second so you can see a little bit better, okay? This length from B to A and B to C are two tangents from the same point to the same circle. And those distances, BA and BC, must be equal. Therefore, it's a kite. All kites are ortho-diagonals. So if I wanted to find the area of this, you've got a lot of options actually. You could do the ortho-diagonal thing, which is half the product of the diagonals. You could drop this in right here from O, and you're creating a 30, 60, 90 triangle. So if I look, you are currently, because you're breaking that 60 right there, you're breaking it up in half, you're going to get 30. The angle down here will be 60. So you could find that now. Let me just draw that out a little bit so you can see what it looks like down there. Okay, this is where A is, that is B on line L, and O is up here, and you have that this is 30 and this is 12. And so if opposite 60 is 12, opposite 30 is divide that by √3 for √3. Therefore, OB is 8√3. 30, 60, 90 properties, a staple, you got to know that. So then 8√3 is your OB. I'm going to use the ortho-diagonal concept. We don't need it. We can just take 4√3 times 12, and the other 30, 60, 90, this one, will just attach right next to it. And you'll have 4√3 times 12 is 48√3 for the area of, I'm basically taking these two 30, 60, 90s and folding them so I get a rectangle. Okay? So when you put them, they're the same exact size, they're congruent. And so 48√3 is OABC, and our radius is 12. What's 12 over 6? 2 times the other 12 that was there, 24 pi. The reason that's going to be the area that we want is, it's hard to draw like a big diagram. What you're looking at is the circle coming here like this, and you're finding this region in here. That's the region that's bounded. And so because of that, it's a terrible drawing, but it's just, we don't have a lot of room on the board here. Because of that, you just need where the sector hits here and here, that whole quadrilateral minus the sector. And that's what this is. This is the OABC region, and that's that. So now we read the ending. Make sure it's right. A, B, and C are positive integers, but wait, that's negative. No. It says minus C. The minus is baked into the formula, so don't worry about the negative. And B is not divisible by the square of any prime. In other words, this radical is simplified. Like √12 would not be okay because it's divisible by the square of 2, which is a prime. So we have that now. This is fine. It's okay to be that. So 48 plus 24, 72 plus 3. The answer is 75. We got one more to go in this rapid fire. All right, and now the last problem in the rapid fire set for 11 to 15 from our 10A. It was also 12A problem 9. Let M, I'm going to do this in two different ways, using two different methods that they're not that much alike. Let M be the greatest integer. This will be important probably once maximize. There's a lot of min-maxing in this task, like where you're trying to maximize or minimize something. Integers such that both M plus 1213 and M plus 3773 are perfect squares. I mean, if they call them perfect squares, maybe we should label them as that. We'll call that one x squared and that one y squared. What is the units digit or ones place of M? Okay, so how are we going to get the greatest integer such that this is true? So the first method that you could do is the one that I started going down right away when I was solving the test. I don't do it for merit, I'm not in school, but I solve it to get a feel for what you guys are experiencing. And so you got two squares, and there's an m here and an m there. Maybe I should subtract because that would make the m go away. And it also creates a common concept in competition math. That is, the difference of squares is created. So why don't we do that? X squared minus y squared is, the 3's cancel, 7 minus 1 will give us a 6. So you're going to have 0 and 6. This 7 in the hundreds place minus that 2 is a 5, and the 3 in the thousands place minus the 1 is a 2. So you get 2560. So at this point, you did this for a reason. You did it so you could factor. Very common plan here is that you have to have this has to be an integer because you're summing two integers, which naturally is an integer. Of course, the set of integers is closed under addition. The set of integers is also closed under subtraction. We know x is bigger than y because I made it that way. This is the bigger number, clearly. And so x minus y is positive, and it will be a positive integer. So then I have the product of these things has to equal 2560. Now, at that point, I thought, my first guess just randomly was, what if x plus y was 256 and x minus y was 10? It's just like a natural product of two things, because since these are both integers, they must both be factors of 2560 that multiply to make 2560. The other thing that you know from experience when doing this is that you want the sum right here to be even. The reason is when you add the left, you have to have an even integer. The y's have canceled out, and so you get here and you get x is 133. Okay, we found something that works. The question is, though, it wants m to be the greatest integer. So now is when you develop this and you have to ask, is this going to produce the greatest value of m? And you're not quite sure, and so you just say, well, how would I know? What would be my actual objective to achieve the greatest integer? And that would be that your x squared is as large as possible. Because if your x squared and your y squared are both as large as possible, then x squared in particular, you're going to make m, if x squared by itself is as large as possible, it will make m be as large as possible. And of course, x squared is maximized when x is maximized. So you can keep going on this path and we will continue, but what I actually did on my test is I didn't perceive what I just told you when I was doing my run through under timed conditions. I went a different route and found the answer in a different way. Okay, and I will go and show you that way in a second, but what I should have done is just said what I just told you, which is that by maximizing x squared, you maximize m, and to maximize this, you just maximize x. Logical, right? So then you say, okay, well, why don't I make this 2,560 and that 1? And again, that's what we just said. That will not give an even sum, and it has to be even, because the left side will always be 2x. Well, if I can't do 1 and 2560, then the next best thing would be 2, right? So if you do 2 and you cut 2560 in half, this could be your x plus y and this your x minus y. And then when you added, you would instead get 1282, which cuts in half to make x is 641. So that's it. That's what x is actually going to be in order to maximize the value of m. And since m plus 3773, if I could write that correctly, m plus 3773 will equal 641 squared. All I have to do is subtract 3773 to get m. Do I actually want m though? No, I want the units digit or ones place. Before you go calculate nasty looking things, to do so, you might think about what it is you're looking for once more before you do those terrible calculations. So if you square a number that ends in 1, what does it end in? It ends in 1, some number that ends in 1. Great. And we're going to subtract 3773, but in reality we only care about that 3. If you have a number that ends in 1 and you subtract a number that ends in 3, you will get, as long as this is a larger number, you will get a number that ends in 8. Okay, not negative might affect that or something, but since this number is clearly bigger than that, then you're going to get a number that ends in 8, and that ends up being the answer. Now, as I said, I was going to show you two different ways, and when I was doing this way and I got to this point, it was like, how do I know if x is the largest? So I said, and I kind of just, I wasn't thinking at the moment, and you're trying to go as quick as you can to get to later problems, clock's starting to tick down, and I said, well, something else I happen to know about squares is that the difference in consecutive squares is the sum of their bases. So I said, well, if these were consecutive, and are they? I don't know. We don't know that, right? If they were consecutive, this would need to be, because that's the difference. If they were consecutive, that's the difference is the sum of their bases. However, if you don't know what I'm talking about, here's an example. 3 squared to 4 squared, the gap between 9 and 16 is 7. But that gap is equivalent to 3 plus 4, the sum of the bases of the perfect squares, okay? Or their square roots, if you will, but bases is easier to say. Okay, so then because of that, I said, well, then this sum is always odd and that sum is even, so if these are squares, they can't be consecutive squares because they would have to have an odd sum, so they must be separated by at least 2. And this is another thing that I've taught myself over time. When you have a difference in squares that is exactly 2 rather, let's say I've got x plus 2 squared and I subtract x squared, you can prove that this is 4x plus 4, which is 4 times the number in the middle. To see what that looks like with numbers, I'll give you an example. From 10 squared to 12 squared, the gap is 44. And 44 is equal to 4 times 11, the number right in the middle of 10 and 12. And that, of course, will always, you have an even number because you're multiplying by 4. So I said, well, if this was that situation, then what would I use? 4 times what is 2560? It's clearly divisible by 4. And you say 4 times, and it would be 640. 4 times 64 being 256. If you don't know why, 2 to the 6 times 2 squared is 2 to the 8th, and 2 to the 8th is 256. And then you just put the 0 on the end. Okay, so then that would mean 640 would have to be the middle number of my 2 perfect squares, so they would need to be 639 and 641, and that is, of course, the same number that we found over here. If you go any larger, like you tried to achieve something larger than using these two, the next thing up, if I did between 640 and 642, let's say, then the product of 4 times these two squares, if you don't understand, 640 squared, 642 squared, their difference now would be 4 times 641, which is more than this number. So there's no way that you could get any larger with your perfect squares. If you dropped lower, like let's say I wanted to make it 642 squared, but I was just going to lower the other square to something farther down, like 639 squared. The problem is the gap is just bigger now. It's even bigger than it was before, so there's no way you're going to have a gap that you need of 2560 between your squares. So if you've worked with that concept a lot, this wasn't hard to conclude that 640 41 was the larger of the two squares, and you reason very much the same at the end with the 1 minus the 3. So that's two different ways. Hope you enjoyed it. Let's get to the next one.